morning students. Today we are going to see capillary action, which is the very important topic in this chapter, mechanical properties of fluid. First of all, we see what they mean by capillary. What is capillary? Capillary is a glass tube with very small bore. Very small bore means the diameter of this glass tube is nearly equal to 1 millimeter and it is open at the both ends. Such glass tube is called as a capillary. Now, what is capillary action? Capillary action means when a capillary is deep inside a liquid, the level inside the capillary either rises or either falls. Such phenomena is called as a capillary action, or it is also known as capillarity. So, in what cases such capillary action takes place? This capillary action takes place when a wick inside a lamp is deep into the kerosene rises with the help of capillary action. The sap and water reaches the top of the tree at the end of the tree due to the capillary action. So, this capillary action we can explain either it is fall or either it is rise. There are two processes which takes place in the capillary action, is rise or fall. Now, in which liquid this rise and fall takes place? The capillary fall takes place in the liquid which does not wet the solid, and the capillary rise takes place in such liquids which wets the solid. So now we are here discussing the two type of phenomena in the capillary action, that is capillary fall and capillary rise. For that, look at here, if the surface is plane, then the pressure at point A is equal to pressure at point B. If the surface or the meniscus is concave, then the pressure on the concave side is greater than the pressure on the convex side. And if the meniscus is like a convex surface, here is point A and B, then we can say that this pressure at point B is greater than the pressure at point A. So, by using these three conditions, we can easily explain the capillary fall and capillary rise in the capillary tube. First of all, we see how the capillary fall takes place. Consider a liquid like mercury which does not weigh the solid is filled inside a dish and a capillary is dipped inside it. So, what happens next? For that, we consider 4 points, point A, B, C and D. So, what about point A? This point A is just lie above the meniscus inside the capillary tube. What is point C? Point C is a point just above the free surface of the liquid inside dish. What is point D? It is just below the liquid surface inside the dish. And what is point B? This point B is just below the liquid meniscus inside the capillary tube. So consider that the pressure at point A denoted by PA and the pressure at point B denoted by PB. Now, by using this condition, the shape of this meniscus is convex. So, what is the pressure? The pressure at point B is greater than the pressure at point A. So, we can write here this pressure at point B is greater than that of A. Now, let's see this point C and point A. Point C and point A both are in the atmosphere. So, the pressure applied at point A and C will be equal. So, we can write here this PA must be equal to PC. So, we can write here as PC is less than PB. Easy. Now, then take this point C and D. This point C and D, they are on the either side of the plane surface, and we know what is the pressure relation. The pressure on the either side must be equal. So we can write here as PC is equal to PD. So we can write here it is PD is less than PB. So what is the difference between the pressure at point D and pressure at point B? The difference is that the pressure at point D is less than the pressure at point B. So what happened then? Due to this pressure difference, the level of the meniscus inside the capillary tube decreases till the pressure at point D and pressure at point B becomes equal. So we can say that when such type of capillary is placed in the mercury, the level of the mercury level in the capillary tube decreases. Such process is called as the capillary fall, which explained on the basis of pressure difference. Now we are moving towards the capillary rise. What is capillary rise? We also consider here a liquid which fully weight the solid, for example water, and we dip a capillary inside the water. So what happens? For that we consider here 4 points A, B, C and D. Suppose the pressure at point A is denoted by PA and the pressure at point B is denoted by PB. So which pressure is greater in this case? We see here this surface is concave, and we know that the pressure of the concave side is greater than the convex side. So we can write here what is the relation between here? The pressure at point A must be greater than the pressure at point B. So now this point A and point C, these 2 points are open to the atmospheric pressure, which will be equal. So we can write here this pressure at point A is equal to pressure at point C, which is nothing but the atmospheric pressure. So we can write here this PC is greater than PB. Now there are 2 points C and D. They are on the either side of the plane surface, and what about this? The pressure on the either side must be equal. So we can write here this PC is equal to PD. So we can write here this PD is greater than PB. So we can see here this is the opposite case. So what happens then? Due to this pressure difference, the level inside the capillary tube rises till the pressure at point B become equal to the pressure at point D. So in such cases, in the case of water, there is a rise in the level of the liquid inside the capillary. Such phenomena is called as a capillary rise. So with the help of these 3 conditions, we can easily explain why the liquid inside the capillary sometimes rises and sometimes falls. It is due to the change of the liquid. Now we can again relate this capillary fall and capillary rise with the angle of contact. Now we see here mercury, and what is the angle of contact for mercury? It is nothing but the obtuse greater than 90 degrees. So the liquid in which the angle of contact is obtuse, then the liquid inside the capillary will fall, and when there is a liquid having the angle of contact less than 90, it is equal to acute angle, then the liquid level inside the capillary will be rising. So what will we see? What we are seeing today? We are seeing that what is capillary? Capillary is a glass tube with a very small bore about 1 meter diameter and open at the both ends. Then we see what is the capillary action. Capillary action means the rise or fall of the liquid inside the capillary due to the pressure difference. This is called as the capillary action. It is also known as the capillarity. Now we see these 3 conditions, and according to these three conditions we explained capillary fall and capillary rise. So in this lecture we have seen all about the capillary action. Here we are going to stop now. In the next lecture we are going to determine the equation for the capillary rise or capillary fall. This is for today. Have a good day.